The practical matter of dealing with electricity in your home, you really just have to remember 3 words.
Hot, neutral, and ground.
And 3 colors.
Black, white, green, and copper. So there are really 4 colors.
Oh, and you forgot red. But we'll get to that later on. These terms and colors are standard in all new wiring across the country. The hot wire brings the current out from the source. This wire is most often wrapped with black insulation. Once the electricity has done its work, it goes back on the neutral wire, which is most often white.
The ground wire offers current another path to ground in addition to the neutral. The ground wire is always either enclosed in green insulation or is bare copper. And remember that electricity needs a complete circuit to work properly, a way out to the job, called the load, and a way back. When you work with wiring, it may not always be obvious that you're dealing with a loop. Well, for one thing, in house wiring, the 2 conductors, or 3 if you include the ground, are usually encased in a single flexible plastic sheath. This is officially known as non-metallic sheathed cable, but it's most often called Romex, which is the brand name of one manufacturer. Romex is what's used in almost all new residential construction, and it's what we'll be using in all of our demonstrations. There's a chart in the project guide which can help you identify other types of wires which you may come across.
When you flip a switch, you actually complete a loop that starts at the power source, flows through the hot conductor to the light bulb, back to the power source through the neutral conductor. Now, there are several devices designed to stop the flow of electricity between the power company and the light bulb should something go wrong. The most important of these are your home circuit breakers. A breaker is designed to turn the power off to trip should too much current try to flow through it. This protects circuits, appliances, and people. For example, if the hot lead and the neutral lead were accidentally connected, it creates a situation called a short circuit. Current will take the easiest path available to it, so it will bypass the bulb and take the direct route back to the neutral, the short circuit. This means that current is flowing through the wires without the resistance of a load, creating a large current flow.
Well, this would be kind of like putting your car in neutral and pressing the accelerator all the way down. Without the resistance of moving the car, the engine would run a lot faster than it was designed to. This would cause the parts to overheat and break.
A short circuit can cause the same sort of damage by overheating the wires and burning the insulation. We'll show you on this demonstration panel. If I intentionally short out the hot and neutral leads, the circuit breaker senses the extra current and turns the circuit off. Obviously, this is only a demonstration. Never intentionally short a circuit. However, there are cases where a short circuit is preferable to an even more dangerous situation. And this is where the grounding system comes in.
Well, suppose the hot lead in this toaster came loose and accidentally touched the metal case. This makes the outside of the toaster electrically hot, and there's a real risk of fatal shock for anyone who touches it.
A grounding system connects the metal frame and case of the toaster to the earth. If a hot wire touches the toaster frame, it immediately creates a short circuit and trips the breaker.
So the power is shut off before anyone can touch it. On grounded appliances, all the metal frames and housings will be connected to the ground wire.
And in the wiring system itself, any metal conduit or boxes are also grounded.
Short circuits aren't the only reason for a tripped breaker. Overloaded circuits are actually an even more common cause. Well, each circuit in a house is designed to carry a maximum load, depending on the area of the house or which appliance the circuit feeds. On our demonstration service panel, the main breaker is rated at 100 amps, and there are 15, 20, 30, and 40 amp breakers for various circuits. If too many devices are running on a circuit, it draws more current than the wiring is designed for, and the breaker will trip, shutting down the circuit. If an older house has been remodeled or large appliances have been added, you may find several types of service panels. You may also find fuses instead of breakers. Cartridge fuses are used for the main and for large appliances, and screw-in usually service the general circuits.
Service panels are tricky, and they can be very dangerous, so we recommend you don't do any work inside of yours.
Instead, hire a licensed electrician to do this part of the job. Now, let's take a look at what our job will involve.